it waits. 100,000 tons of nuclear-powered steel sitting in the Red Sea, 11 advanced weapons elevators, 4 electromagnetic catapults capable of launching a fully loaded I-18 Super Hornet every 45 seconds at surge rate, the world's largest warship, the most expensive weapon ever built at $13 billion per hull, and it has been at sea for over 300 days. In March 2026, a fire broke out in the laundry room of USS Gerald R. 100 sleeping berths were destroyed. 200 sailors were treated for smoke exposure. The ship left the Red Sea combat zone and sailed to Split, Croatia for repairs. The Navy spent 5 days patching it. Then it sent the ship back to Operation Epic Fury. 5 days. Nuclear carriers typically require 6 to 12 months of post-deployment maintenance. The Ford got 5 days and a port call in Croatia. The Navy's most advanced carrier, the ship designed to replace 50 years of Nimitz-class technology, the platform that was supposed to generate 25% more sorties, carry 25% more ordnance, and fight for 50 years until 2070, is held together by acid flushes in its plumbing system and sailors working 19-hour shifts. And right now, in a shipyard on the East Coast, the Navy is loading a Nimitz-class carrier for deployment. To replace it. July 22, 2017, Norfolk Naval Station. Secretary of Defense James Mattis stood on the flight deck of USS Gerald R. for its commissioning ceremony. The speech was about transformation, about the future, about an aircraft carrier so advanced that it would define naval warfare for the rest of the 21st century. None of Ford's 11 advanced weapons elevators worked that day. Not one. The ship the Navy commissioned with full ceremonial honors, the band, the flags, the Secretary of Defense, could not move ordnance from its magazines to its flight deck. Contractors worked for 4 more years to fix them. The ship achieved initial operational capability in December 2021, 12 years after keel laying, 6 years after its original delivery date. The EMALS catapult system, the electromagnetic replacement for steam catapults that had launched aircraft reliably since the 1950s, was designed to complete 4,166 cycles between critical failures. In 2019 operational testing, it averaged 181 cycles. That is a ratio of 23:1 between promise and performance. In testing, not in combat, not in the Red Sea during sustained strike operations against Iran. The program cost $13 billion for the lead ship, $2.8 billion over original estimates. The sewage system, redesigned as a vacuum system modeled on commercial aircraft technology but scaled to a 4,500-person crew, clogged so persistently that the Navy recommended quarterly acid flushes to clear calcium buildups in its pipes. The most advanced warship in history required the same chemical treatment as a corroded residential drain. Now that ship is in its 10th month of continuous deployment, and the Navy is reaching back to 1970s technology to take its station. Now imagine that reliability gap not in a port in Norfolk, but during a 24-hour surge operation against Iranian coastal defenses, when every catapult failure means aircraft that don't launch and targets that don't get hit. That is not a hypothetical. That is the operational environment the Ford is in right now. The paradox. So here is the question that nobody in the defense establishment wants to answer directly. The U.S. Navy spent $13 billion building the future of naval warfare. It spent 12 years getting that future operational. It deployed it to the most demanding combat environment since the Gulf War. And after 300 days at sea, a fire, a sewage crisis, and 5 days in a Croatian port, it is sending a 2009 Nimitz-class carrier to take its place. Why does the most expensive naval innovation in American history keep getting bailed out by the technology it was designed to replace? Because innovation and reliability are not the same variable. And in war, only one of them decides whether the aircraft get airborne. Enemy Decoded doesn't cover what happened. It calculates why it had to happen and what it means for the next move on the board. If that's the kind of analysis you're looking for, you're in the right place. The adversary reveal. Iran did not need to sink USS Gerald R. Ford. It needed the Ford to be unavailable. It needed the carrier to be in a Croatian port having smoke damage repaired while CENTCOM was running 13,000 target strike packages across the Iranian interior. It needed the EMALS system to drop below surge rate reliability when the sortie demand was highest. It needed the weapons elevators, the ones that took 4 years of contractor work to certify, to become a constraint rather than an advantage in the middle of the largest U.S. air campaign since the Gulf War. Every day USS Gerald R. Ford spent in Split was a day the U.S. had 11 of Abraham Lincoln's F/A-18S doing the work designed for 2 carrier air wings. Every EMALS failure on the Ford during surge operations shifted sortie load to the Nimitz-class carrier beside it. Iran did not attack the Ford. It did not need to. It needed the Ford to be exactly what it has been, a ship that required more maintenance care than the operational environment could provide, absorbing crew energy and command attention that a combat campaign of this scale could not spare. The cost ratio is not Iranian mines versus American destroyers. It is 181 EMALS cycles versus the 4,166 the system was designed to deliver. Iran wins that equation every day the catapults run at 4% of design reliability. The obvious answer to the Ford's limitations is fix them. The Navy has been doing exactly that for 9 years. Here is what 9 years of fixes produced. EMALS, designed for 4,166 cycles between failures. 2019 testing delivered 181. 2022 testing delivered 600. 600 is a number that sounds better than 181 and is still 85% below the design goal. In surge operations during Operation Epic Fury, those catapults have been running at a tempo that compresses the maintenance intervals further. Advanced arresting gear, designed for 16,500 cycles between failures. Operational testing found it breaking down after approximately 450 cycles. That is a gap of 97% between specification and performance. The aircraft that land on the Ford's deck are recovering on a system that works at 2.7% of its designed reliability interval. Advanced weapons elevators. 109 failures reported out of 20,000 dispatches during one weapons onload. The Navy called this varsity numbers. 109 failures in a single weapons loading evolution, on the system that was supposed to be 200% stronger and 150% faster than the Nimitz. Those failures each represent a pause in the ordnance flow from magazine to flight deck. In sustained combat operations, each pause is measured in sorties that do not happen on schedule. Sewage, a vacuum system requiring acid flushes to clear calcium buildup. Sailors on a 4,500-person warship managing a plumbing crisis while flying combat missions in the Red Sea. After the March 2026 fire, the Ford spent 5 days in Split, Croatia. The Navy declared it combat ready. The ship's 9 months of sustained high-tempo operations across the Arctic, Mediterranean, Caribbean, and Red Sea had created a maintenance backlog that 5 days could not address. The deeper problems were deferred. They did not disappear. This is not a list of failures. This is a pattern. The pattern says, Every system on the Ford was first of its kind. First of its kind means no operational history. No failure mode knowledge. No failure mode knowledge means the first sustained combat deployment is also the first real stress test. And the first real stress test is happening in the middle of the largest U.S. air campaign since shock and awe. Iran built its strategic deterrence around a specific assumption about American carriers. It assumed the U.S. would be reluctant to risk a $13 billion hull inside the Persian Gulf's contested geometry. It assumed the carrier strike groups would operate from standoff distance, limited by the same caution that protects irreplaceable assets. It built its island fortresses, its mobile launchers, its mine strategy around a defender who keeps the most valuable piece off the board. It did not plan for the most valuable piece to take itself off the board. The Ford-class review that Secretary Phelan announced on April 22, 2026, is not just a procurement decision, it is an operational verdict. When the Navy Secretary publicly raises the possibility of canceling planned Ford-class orders during the largest U.S. naval combat operation in 30 years, he is acknowledging something that no test report had been able to force the institution to acknowledge: that complexity without proven reliability is not a capability. It is a liability wearing the uniform of a capability. The last Nimitz is deploying, not because the Nimitz-class is superior, because it is available, reliable, and proven in exactly the sustained high-tempo environment that broke the Ford's laundry room and its operational tempo in the same month. That is a dimension that $42.5 billion in Ford-class procurement did not buy. The Nimitz doesn't deploy alone. USS Abraham Lincoln has already been running the carrier air wing that the Ford's reduced sortie rate couldn't fully cover. When the last Nimitz takes station, it doesn't replace a single ship. It completes a layer. Lincoln handles the sustained strike tempo. The incoming Nimitz handles the surge capacity. Together, they provide what the Ford was designed to provide by itself. But the more significant layer is what the Ford-class review makes possible structurally. Secretary Phelan's April 22 announcement isn't just about one ship. It signals a systemic reorientation, away from concentrated first-of-class complexity and toward distributed, proven reliability. The carrier doesn't have to be the most advanced system in the fleet. It has to be the most dependable node in a network. Where destroyers carry Tomahawks, submarines carry cruise missiles, and B-52s fly from Diego Garcia at 60,000 feet. The system that works is not a single $13 billion hull. It is a grid of proven assets that don't require 5 days in a Croatian port to stay operational. The Ford was built to be the center of that grid. The Nimitz is proving it doesn't have to be. Iran spent decades designing its deterrent strategy around a specific fear. It wargamed American hesitation. It built island fortresses in the Strait of Hormuz because it calculated that no U.S. commander would risk a $13 billion carrier inside contested Persian Gulf geometry. It developed swarm tactics, fast attack craft, and anti-ship missiles calibrated to the threat model of a U.S. Navy that would keep its most valuable asset at standoff distance. It never wargamed a scenario where the most valuable asset removed itself from the equation, not through Iranian action, but through its own maintenance schedule. The Ford-class reliability gap handed Iran something no missile battery could have achieved: a 10-month window in which America's most advanced carrier was simultaneously present and constrained, available but not fully operational. Deployed but managing a laundry room fire, calcium buildup in its plumbing, and catapult systems running at 14% of their designed surge capacity. Iran planned against American caution. it did not plan against American engineering debt. That is not a tactical gap. That is a strategic blind spot. And the Nimitz deploying to fill it is the answer that closes it. This doesn't resolve the fundamental question. The Nimitz is 50-year-old technology. It is reliable precisely because it has no new variables. Every failure mode has been cataloged. Every maintenance interval refined across decades of operation. But it also has no growth path. The electromagnetic catapults that the Ford promises, when they work, genuinely do represent the future of carrier aviation. Longer range, heavier payloads, lower wear on airframes. The Ford-class program isn't wrong about where naval aviation needs to go. It is wrong about the timeline and the cost of getting there. For the equation to fully close, the Navy needs a Ford-class that delivers 4,166 email cycles, not in a test brief, but in the Red Sea. That variable hasn't moved yet. And until it does, every next-generation carrier the U.S. commissions carries the same structural risk. A platform whose reliability is still being discovered in the field it was designed to dominate. Beat 11. The close. The equation hinges on three variables: sortie rate promised versus sortie rate delivered under 9 months of sustained combat. Maintenance intervals designed versus maintenance intervals available when the operational demand does not pause for a carrier's schedule. And the cost of concentrated first-of-class innovation when certainty is what war requires and reliability is what keeps aircraft in the air. The Navy's review will conclude within a month. The last Nimitz is completing its pre-deployment workups now. USS Gerald R. Ford is still somewhere in the Red Sea, the longest deployed carrier since Vietnam, carrying a crew that has worked 300 days to prove a $13 billion platform under conditions no test environment could replicate. Whether the Ford's performance vindicates the program or condemns it is the question the review is designed to answer. The last Nimitz deploying to take its station is the operational answer that arrived first. Enemy Decoded explains what others won't.